Welcome back to the Deep Dive. We're here to sift through complex sources, find those key pieces of knowledge, and help you get up to speed fast. Today, we're diving into something huge, really fundamental, artificial intelligence risk. Specifically, we're tackling Chapter 2, Part B, of the AAISM Official Review Manual. The title is Threat and Vulnerability Management, all in the context of AI. And, as we started prepping for this, something jumped right out at me from the very beginning of this chapter. It paints this really vivid picture of how AI is, well, everywhere now, changing global society. It talks about reshaping how we interact, how we work, even creating new art, new music. I mean, it's a massive shift. But then it adds this really interesting, maybe slightly worrying detail, a concern about authenticity and the dilution of traditional experiences. That really made me pause. It's a deep thought, right? What does it actually mean when these tools, the ones designed to help us to expand our world, also bring in these new really complex risks, maybe even risks to what we think of as real?
That's such a critical starting point. It really frames why understanding AI threats is just absolutely non-negotiable now. And what's fascinating, as you said, is how the very things that make AI so powerful, its ability to generate incredibly real-looking content or automate complex decisions or personalize things down to the individual level, those exact capabilities are also creating entirely new ways for things to go wrong, new threat vectors. So if we connect this to the bigger picture, the more AI gets woven into, well, everything business, government, just our daily lives, the more vital it is to map out not just the upsides, but the vulnerabilities too. And this isn't just, theoretical security stuff. We're talking about protecting actual businesses, actual people, society itself from new kinds of harm. Harm that could be financial loss, sure, but also reputational damage, or even these deeper ethical problems like that authenticity concern you brought up. Imagine trying to tell human-made from AI-made content when it's virtually identical, or critical decisions being made by algorithms we don't fully understand, potentially amplifying biases. So yeah, understanding this whole landscape of AI threats, it's essential. Doesn't matter if you're designing these systems, managing them, or just living in a world shaped by them. You need to know this stuff. It's not a side issue anymore. It's core.
That's a really powerful way to put it. The more powerful the tech, the more we need to understand the potential downsides. Okay, so let's dig into how the manual helps us do that. It moves into section 2.7, focusing on the threat landscape. And it's very clear this isn't just general cybersecurity. It's specifically about the threats and vulnerabilities presented by the use of AI, the unique challenges AI brings. Now, as I was going through this, figure 2.14 really caught my eye. It's called the AI Threat Conceptualization Example. And it's not just a list of bad things that can happen. It's more like a map. It shows how these threats are connected, almost like a system diagram for AI risk. You see how one vulnerability might lead to another, cascading effects. It puts AI right there in the middle and then shows all these categories radiating out. It immediately tells you, okay, this is complex. It needs a holistic view.
Exactly. That diagram is incredibly useful because it tackles a fundamental question. How do we even start to organize our thinking about all the potential problems with something as dynamic and, frankly, as fast-moving as AI? It gives us a structure, a framework. It helps move us away from just vague worries about AI taking over and towards a systematic way to think about specific risks. It lets us visualize them, categorize them, and ultimately start planning how to manage them. And it shows really clearly that AI threats aren't just one thing. They come from different places, the design, the data, how it's used, the infrastructure, and they impact different things, the organization, its customers, society. Seeing AI at the center and then mapping out how threats emerge from its interactions, its design, its use, even its development stages, that comprehensive view is key. It helps us figure out where to focus our efforts, where to put resources to get the biggest impact on reducing risk.
All right, let's break it down then. Starting with AI at the center, what are those first arms reaching out? The direct threat categories that come from AI itself. Okay, so radiating right out from that central AI bubble, we see things like abuse, deny, and steal. Now, those terms might sound familiar from general security talk, but the manual implies they take on a whole new dimension with AI. Let's take abuse. This is about someone maliciously using AI's capabilities, turning it into a weapon, basically. Think about AI generating super convincing phishing emails, tailored to each person, at a massive scale, way beyond what humans could do.
Right, or crafting sophisticated propaganda, deepfake videos maybe, or fake news articles, all personalized, maybe even translated instantly.
Yeah, undermining trust in information itself. It's not just one attacker fooling one person anymore. It's about scale and sophistication.
And that scale is a key part of the abuse category here. AI allows a small group, or even an individual, to potentially have a huge impact, creating highly deceptive content or launching widespread attacks that just weren't feasible before. It changes the whole dynamic of cybersecurity threats.
Okay, then there's deny, making AI systems unavailable.
Yeah, and again, think AI specific. Not just hitting a web server with traffic, it could be targeting a crucial AI API, maybe an AI that does fraud detection for a bank or manages a supply chain's logistics in real time.
Taking that offline would be catastrophic.
Exactly. Imagine the financial losses if a bank's AI fraud system is down even for minutes. Or the chaos if a major logistics AI stops working. And these deny attacks can get sophisticated too, maybe exploiting how computationally intensive AI can be or targeting its specific data feeds. It requires understanding the AI's unique weak points.
And the third one in that group is steal, which with AI sounds like it goes way beyond just stealing data.
It really does. Steal here isn't just about grabbing customer lists, though that's bad enough. It's about stealing the AI itself, or the valuable stuff that makes it work. Think of the intellectual property. Someone stealing a company's highly trained AI model that could represent years of research, millions in investment.
So stealing the actual model file.
That's part of it, definitely. That's direct IP theft. But it's also about stealing the training data, which might be proprietary or contains sensitive personal info. And there are even sneakier ways. Things like model inversion attacks.
Model inversion, what's that?
It's where an attacker, maybe just by querying the AI model through its public API, can actually start to reconstruct parts of the private data it was trained on.
Wow, so even if they don't steal the model itself, they could steal the data through the model.
Potentially, yes.
Yep.
It's a really complex area, but it highlights how steal in AI can be much more subtle and damaging than traditional data theft. You're losing your competitive edge, maybe facing huge privacy violation fines. Even if the model technically never left your servers, it's a serious threat.
Okay, that makes sense. So those are the broad direct threats: abuse, deny, steal. But the diagram gets more specific, right? It calls out large language models,
Yep.
LLMs. Yeah, there's a specific branch for LLM and its own set of unique threats: biased, toxic, and fake. These feel very current, very relevant to what we see in the news. Let's start with biased. The idea that the training data can bake societal biases right into the AI, leading to unfair outcomes.
Exactly. And this isn't just theoretical.
Right. The manual gives a concrete example here. It cites research from the University of Washington. This is on page 105 for those following along in the manual, finding social and gender bias in AI tools looking at job applicants' names. It's a really stark example. An AI meant to help hiring might actually filter out good candidates just because their name triggers a bias learned from the data.
It's a perfect illustration. LLMs learn from vast amounts of text data, mostly scraped from the internet. And, well, the internet reflects our society, including its biases. So if the data contains historical biases against certain groups, the LLM learns those patterns. And it might reproduce them, often subtly, but at scale.
And it seems objective, right? Because it's an algorithm.
That's the danger. It can lend a veneer of objectivity to what is essentially encoded prejudice. It raises that critical question. How do we curate these massive data sets? How do we audit the models for fairness? It's a huge challenge, and it needs ongoing work, not just a one-off check.
Okay, moving to toxic. This is about the AI generating harmful or offensive content.
Yeah, think hate speech, harassment, maybe instructions for harmful activities, or just generating really inappropriate stuff.
And with LLMs being so good at generating human-like text,
It becomes hard to police. An LLM can generate vast amounts of content, way too much for manual review, and toxic can be really context-dependent.
so simple keyword filtering won't cut it.
Not really. The models can be prompted, sometimes subtly, to produce harmful output that might bypass basic filters. It's an ongoing arms race between generation and detection. We're trying to identify harmful intent, bias, dangerous misinformation, not just bad words.
Which leads us nicely to the third LLM threat: fake. Creating synthetic media, deepfakes, spreading misinformation.
And this is getting alarmingly good. AI can create fake video, fake audio, fake images, fake entire online personas that are incredibly difficult to distinguish from reality.
Deepfakes are the obvious example, mimicking someone's voice or likeness.
Right. But also just generating plausible sounding but completely fabricated news articles, fake reviews, fake social media campaigns. It fundamentally challenges our ability to trust what we see and hear online. If anything could be fake, how do you verify truth?
It creates that liar's dividend you mentioned earlier.
Exactly. Even real information can be doubted. This erodes trust across the board in media, in institutions, even in personal interactions. And think about the implications for elections or public health crises or financial markets. The potential for disruption is immense.
So it's another arms race. AI generating fakes and AI trying to detect them.
Pretty much. And we need more than just tech solutions. We need better digital literacy, stronger verification methods, clear ethical guidelines for developers. It's a whole of society problem.
Okay, so we've covered direct threats and LLM-specific ones. The diagram also points to something that sounds maybe less dramatic, but the manual stresses its importance. Inefficient. This branches into things like unstable, algorithm flaws, and resource-intensive. Why is inefficiency considered a threat?
Well, it might seem less direct than, say, abuse, but inefficiency can cripple an AI system or the business relying on it. It highlights that risk isn't always external or malicious. Take unstable. An AI system that performs inconsistently, gives unpredictable results, or crashes frequently.
That sounds like more than just an annoyance.
Absolutely. If it's an AI and a self-driving car, instability could be fatal. If it's a medical diagnostic tool, unreliable results could lead to misdiagnosis. Even in business, an unstable trading algorithm could cause huge financial losses. It destroys trust and reliability.
Then there's algorithm flaws. These are fundamental problems in the AI's core logic.
Right. Not just a coding bug, but a deeper issue in how the algorithm itself works. Maybe it makes consistently suboptimal decisions, or it has a subtle weakness that only shows up under specific conditions.
Hard to detect during testing, maybe.
Very hard sometimes. These flaws might mean the AI just doesn't work as intended, maybe misidentifying things or making biased decisions, not because the data was biased, but because the algorithm itself has a flaw. Or it could create a vulnerability. An adversary might discover this algorithmic weakness and figure out how to feed the AI-specific inputs to force a wrong, predictable output. That's an adversarial attack exploiting a core flaw.
And the last one under inefficient is resource intensive.
Yeah, AI systems that just need massive amounts of computing power or energy.
Which sounds like a cost issue mainly.
It is a cost issue, and that can be a threat in itself. If an AI is too expensive to run, it's not viable. It might be unsustainable, especially long-term or in places without huge resources, but it's also a potential vulnerability. If an AI uses tons of resources for every query, someone could potentially launch a denial-of-service attack just by sending it lots of legitimate but computationally heavy requests.
So you overwhelm it with normal work, essentially.
Exactly. You exhaust its resources without technically hacking it. So operational cost becomes an attack surface. Plus, the environmental impact of highly resource-intensive AI is increasingly seen as a risk factor, too.
So inefficiency isn't just about slow performance. It hits reliability, cost, security, and even sustainability.
Precisely. It's a really important category that shows risks can be inherent to the AI's design and operation, not just external attacks.
Okay, let's shift focus slightly. The diagram also includes boxes representing components or interaction points: provider, AI system, and UI. What risks emerge from these?
These represent different stages or actors in the AI lifecycle, and each brings its own potential problems.
Like provider. That sounds like supply chain risk for AI.
That's a great way to put it. Many organizations don't build all their AI from scratch. They use third-party models, platforms, APIs.
So you inherit their security posture.
You inherit their risks, basically. If the provider had insecure development practices or used biased data, or if their platform has vulnerabilities, you're exposed. It requires really rigorous vendor risk management, understanding how they built and secured their AI, not just assuming it's safe because it comes from a big name.
Then AI system itself, the internal architecture.
Right. This is about flaws baked into the design, how the data flows, how the model is structured, the infrastructure it runs on. Vulnerabilities introduced during the actual engineering process.
And UI, the user interface. How does risk come from there?
The UI is where humans interact with the AI, so it's a critical point. You can have things like prompt injection attacks, where a user crafts a clever input to trick the AI into doing something it shouldn't, bypassing its safety controls.
Like telling a chatbot to ignore its previous instructions.
Exactly. Or just a poorly designed UI could lead to users misunderstanding the AI's output or capabilities, causing them to misuse it or make bad decisions based on its advice.
Which connects directly to the next items branching off these: misunderstanding and end user. These seem like the human factors in AI risk.
Absolutely critical factors. Misunderstanding is huge. If users don't understand what an AI can really do, what its limitations are, how confident its outputs are, They might overtrust it or use it inappropriately.
Like taking an AI's medical suggestion as gospel without consulting a doctor.
Precisely. Or misinterpreting the confidence score from a facial recognition system, leading to potentially harmful decisions based on a misunderstanding of the AI's output.
And end user covers things like simple mistakes or even insider threats.
Yes. An end user might accidentally misuse the AI because they weren't trained properly, or they might intentionally misuse it. Think of an employee using an internal AI tool for unauthorized purposes. That's an insider threat. It really highlights that human-AI interaction is a major source of risk. It's not just about the technology itself.
It raises that question, how much risk is technical versus human?
The diagram suggests it's deeply intertwined. A perfect AI system can still lead to bad outcomes if users misunderstand it or misuse it. A flawed UI can amplify those risks. It really drives home the need for clear communication, robust training, intuitive interfaces, and considering the human element at every stage of AI design and deployment. Security isn't just code, it's people and processes too.
Okay, circling back to the main AI bubble one more time. There are three really big high-level risk categories branching off it: privacy, security, and compliance. These feel like the ultimate impact areas.
They absolutely are. You could almost see them as the ultimate consequences of many of the other threats we've discussed. Whatever the initial vulnerability, bias, instability, abuse the outcome often manifests as a failure in one of these three pillars.
Let's take privacy. AI systems often need vast amounts of data, sometimes very personal data.
Exactly. So the risks involve how that data is collected, stored, processed, and protected. Is personal information being exposed? Are there strong data governance practices?
A privacy breach involving AI processed data could be massive.
Huge. Not just the reputational damage and loss of trust, but potentially crippling fines under regulations like GDPR or CCPA. Privacy is paramount when dealing with the kind of data AI often uses.
Then security. This is about protecting the AI system itself.
Right. Ensuring its integrity, it hasn't been tampered with, its confidentiality, models and data aren't stolen, and its availability. It works when needed, connecting back to deny. It's about hardening the AI against attacks, preventing unauthorized access, ensuring its outputs can be trusted, and resisting manipulation. A security failure could lead to anything from data theft to the AI making dangerous decisions because it was compromised.
And finally, compliance. Keeping up with laws and regulations.
Yes, and this is a really tricky area because the legal and ethical landscape for AI is evolving so rapidly. We're seeing new AI-specific laws emerging globally.
Like the EU AI Act.
Exactly. Organizations need to ensure their AI systems comply with existing data protection laws, non-discrimination laws, and these new emerging AI regulations and ethical standards.
Failing to comply could mean huge fines, legal battles, being forced to pull systems from the market.
And significant damage to the organization's reputation. Compliance isn't just a legal checkbox. It's fundamental to building trustworthy AI that society will accept. So these three, privacy, security, compliance, are really the bottom line for organizations. Failure here can undermine the entire AI initiative, maybe even the business itself. They need to be baked in from the start.
Okay, that makes perfect sense. Now, the final piece of this diagram, down at the bottom, is threat contextualization. This seems crucial for understanding how and when threats actually happen.
Absolutely vital. Knowing what the threat is, like abuse or bias, is one thing. Understanding the context, the when and how, is key to actually preventing or mitigating it effectively.
So the diagram breaks this down. First, timing. Is it happening in production or during development?
Right. A production threat is happening to a live deployed system, maybe an active attack or an issue discovered during operation.
Whereas a development threat is introduced earlier.
Exactly. Maybe poison training data was used, or insecure code was written, or a flawed design was chosen during the building phase. The vulnerability is created during development, even if it's only exploited later in production.
And knowing the timing changes how you respond.
Completely. Development threats need better secure design practices, more rigorous testing, data validation. Production threats need monitoring, incident response, patching for live systems, different tool sets, different processes.
Then there's action. The diagram splits this into unintentional and intentional.
A really important distinction. Was the vulnerability created by accident or on purpose?
Unintentional includes things like insecure design, just an honest mistake or oversight.
Yes, maybe due to complexity or lack of specific AI security knowledge.
Right.
Or a backdoor left in accidentally. Maybe from debugging code that wasn't removed. Harmful, but not malicious in origin.
So for unintentional issues, the fix is Better processes, more review, better testing.
Generally, yes. More threat modeling specific to AI, better code scanning, more thorough design reviews to catch those accidental flaws before they get deployed.
Okay, but intentional actions are different. This is malice. The diagram lists crypto failure.
Yeah, not just any crypto attack, but one specifically targeting the cryptography used to secure the AI's data or operations. Maybe trying to break the encryption on sensitive training data or compromise the integrity checks on the model itself.
And also insecure design again, but this time intentional.
Right. This is where an attacker deliberately introduces a vulnerability during development, sometimes called AI trojaning. They might subtly alter the model or data to create a hidden backdoor.
A backdoor that only activates under specific conditions.
Often, yes. It could be triggered by a specific input pattern, making it incredibly hard to detect during normal testing. It lies dormant until the attacker chooses to activate it, potentially causing the AI to misclassify things, leak data, or perform some other malicious action.
That sounds incredibly dangerous and hard to defend against.
It is. Detecting intentional hidden backdoors requires very specialized techniques, often involving deep analysis of the model's behavior and potentially AI-powered detection tools themselves. It really elevates the threat level.
Finally, under contextualization, there's negligent. This isn't malicious, but it's not exactly accidental either.
It stems from a lack of due care, poor practices, like misconfigured security. Someone just didn't set up the security controls properly. Maybe they left default passwords on an AI platform or didn't secure an API key correctly.
Basic security hygiene, essentially.
Exactly. But often overlooked, especially with complex new systems like AI, and use outdated components running the AI on old software or libraries with known vulnerabilities that haven't been patched.
That seems like a constant battle in IT.
It is, but the interconnectedness of AI systems, the frameworks, the libraries, the infrastructure makes it critical. A vulnerability in one component can compromise the entire AI stack.
So this whole threat contextualization piece really helps you zoom in on the root cause and figure out the right way to tackle it.
Precisely. It moves you from a generic awareness of risk to a specific diagnosis, which is essential for effective treatment, so to speak. Understanding the when timing, the intent, action, and the operational context, like negligence, guides your entire security strategy.
So wrapping this section up, what does this all mean for you, the listener?
We've really taken a deep dive into Chapter 2, Part B of the ISAC manual, using that figure 2.14 in the AI threat conceptualization example as our guide. And I think the biggest takeaway is just how interconnected and multifaceted AI threats really are. It's not one simple thing. It's this web of technical issues like algorithm flaws, specific LLM problems like bias and fakes, direct attacks like abuse and theft, operational issues like inefficiency, and critical human factors like misunderstanding or provider risk. And understanding that context when and how these threats emerge, whether they're intentional or just negligent, is absolutely fundamental. This framework helps you see that whole complex picture, moving beyond just reacting to problems towards actually anticipating and managing AI risks strategically. Absolutely. And if we connect this to the bigger picture, AI isn't standing still. These systems learn, they evolve, new capabilities emerge constantly. That means our approach to managing their risks has to evolve too. It can't be static. Continuous monitoring, continuous learning, continuous adaptation. These aren't just nice to haves. They're essential for building AI we can actually trust. This threat conceptualization from ISACA is a powerful tool for that, helping organizations shift from being reactive to being proactive and strategic. But the real value comes from applying it. So maybe the question to leave you with is this: how might understanding this complex web of AI threats, seeing how they connect, as shown in Figure 2.12, how might that change how you think about AI safety, whether it's in your work, in developing or deploying AI, or even just in how you evaluate the AI systems you interact with every single day? What new questions does this raise for you? What will you look at differently now?
That's a great question to ponder. This has definitely given us, and hopefully you, a much clearer, more structured way to think about the challenges of AI security. Take these insights, mull them over, see how they apply in your world. We'll be back soon with another deep dive. Until then, stay curious, keep digging.